All right, welcome to class. We are now on perfecting the squares, which is basically most students was the method to solving quadratic equations, right? But it's not so bad actually once you get the hang of a few concepts. Um, so I did this here just to let you know that this is a new skill you're learning, right? It's something you're going to use even outside of the idea of finding the solutions to quadratic equations. And is also, I think, the skill that gives you the most insight into quadratics. I would explain that later on. Okay, so we'll look at two main concepts here. The first one is how to write as a perfect square trinomial. Perfect square trinomial means, of course, a perfect square means, say if I have 4, right? If I have 4 squared, that gives me 16, which makes 16 a perfect square, right? Makes 16 a perfect square. If I have, since 3 squared gives me 9, it makes 9 a perfect square, right? And it means that the square root of 9 is 3, which you can easily find. Good. So there's a relationship between binomials, square binomials, and the perfect squares, which will be trinomials, right? And we'll try to just see if we can come up with that. So for this one, we have, if I say to square this, is going to be, of course, x minus 3 multiplying x minus 3, which gives x squared minus, that'll be minus 3x, so minus 6x, right, plus 9. So I collected the like terms already in my head, but you can multiply it out and see that it gives you that. This one here gives me x plus 5 by x plus 5, which would be x squared plus 10x plus 25, right? X squared plus 10x plus 25. Again, you can do it and collect the like terms. It's just one step I skipped. Okay, this one I wouldn't skip any steps, right? Because I don't want us to get confused. This is x plus 3 all squared. Okay, good. So we're going to have x plus 3 over 2. We're going to multiply x plus 3 over 2. Good. So x times x gives you x squared. X times 3 over 2 gives you plus 3 over 2. 3 over 2 times x gives you plus 3 over 2 again. 3 over 2x I meant to say. And then 3 over 2 times 3 over 2 gives you 9 over 4. 9 over 4. So if you add up the like terms in the middle, it's basically going to be x squared plus 3x plus 9 over 4. Right? Okay. Then the final one is x minus 6 all squared. Okay, good. So this is going to be well, that would be x minus 6 by x minus 6, which is basically going to be x squared minus 6x minus 6x. That would be minus 12x plus 36. Minus 12x plus 36. Okay, so I'm going to wipe off this and just write down the answers. Then let's see if we can pick out a relationship between both of them. So I'm going to just erase all ink from slide. I think I can remember the answers. This was x squared minus 6x plus 9. This was x squared plus 10x plus 25. This was x squared plus 3x. I think that was plus 9 over 4. And this was x squared minus 12x plus 36. Good. Okay, so these were the answers we got, right? And these are the same thing, right? This one and this one are the exact same things. The idea is that we just want to, they're expressed in different forms. So let's see. What I want to teach you is a way to go from here to here and to go from here back here, right? It's just a way to go from here to here and to go back here without having to expand or factorize, because we'll be doing it a lot. And so once you know that is a perfect square, right? Once you know that it's a perfect square, you can easily go back and forth. Good. So that's the first thing. All right. Next, is there any relationship in perfect squares that we can notice? I'll just give you the gist right away. is that if you notice for all these ones, right, your value for A is 1. So that's the first thing to note. Your value for A is 1, right? So for you to rewrite as a perfect square, you need to get the value of A as 1. And secondly, your value of C is equal to B over 2 all squared. If it's a perfect square, right? Let's try them out. Let's try them out. This is a perfect square, right? This is a perfect square trinomial. So let's do B over 2 all squared. That would be minus 6 over 2, and then we square it. That would be minus 3 over 2, right? And minus 3 rather, which when you square it gives you 9. So that means that you can see is 9. 9 is our C for this one. Let's try for this one. That would be 10 over 2 all squared, which gives you 5 squared, which gives you 25. This one would be 3 over 2, right? B over 2 is 3 over 2. When you square it, you get 9 over 4. And then the last one is minus 12 over 2, which gives you minus 6, which gives you 36. So what we've learned is that for you to recognize, pick out a perfect square, your B over 2 all squared will be the same value as your C. So if you see a trinomial, the way you know that it's a perfect square is that when you divide your B by 2 and square it, you get the value for C, right? So we'll be playing around with that also later on. The second thing that we'll look at now is how to easily go back and forth, right? How to go back and forth. That's to say, I know I have a square binomial, or is a perfect square trinomial. How do I write it as a binomial? Good. How do I write it as a square binomial? This is a perfect square trinomial. How do we know? You can divide this by 2 and square it and you will get 36. Right? So we know it's a perfect square. But what is the square root, right? How can I write it as something squared? Okay, good. Now for that, all you do is you divide b by 2 and you drop it here. So this is going to be x minus 12 over 2 is 6. So minus 12 over 2 gives you minus 6. So this is basically x minus 6 squared. And you can try it out yourself. Okay, so that's how you go from square binomial to, from a perfect square trinomial to a square binomial. Let's try again. Let's look at this one. This is a perfect square, right? And how do I know? Because 5 over 2, 10 over 2 is 5, and 5 squared is 25. 10 over 2 is 5, 5 squared is 25. So that means that if I want to change this, it's simply going to be x plus, again, I divide 10 by 2, x plus b over 2, so that will be 5 all squared. And you can expand this, and that gives you that, right? So here are the last two. Pause the video and try to do them by yourself. Okay, so let's check out our answers now. X squared plus, okay, that's one too many pluses, so I'll take that out. So x squared plus 7x is equal to that. Now I know it's a perfect square because 7 over 2 all squared gives me this, right? So my answer would be x plus 7 over 2 squared, right? B over 2 squared. For this one is going to be, is it a perfect square? Yes, it is, because 4 over 2 squared gives you 4, right? So this would be x plus 2, because that's b over 2 squared. Good. All right, so we've done it already. We should be good by now. It's very simple, right? The first thing we learned is that for you to have a perfect square trinomial, two rules must be met. We said a must be equal to 1, and c must be equal to the value of b over 2 squared, all squared, right? And so once you see a trinomial that meets this rule, you know that it's the square of some binomial. It's the square of some random binomial. The next thing we said is, once you know it's a square of a binomial, how do you write it as that? We said you just do basically x plus b over 2 all squared, right? X plus b over 2 all squared. So once you show it's a binomial, it's a perfect square trinomial, you can write it as a square binomial by doing this. All right, thank you. So we'll leave it at that. I think in the next slide we'll have a number of questions to practice with. So just click the link, watch the video, after you've tried them out, and you should be good. All right.